Okay. In 1971, Intel released its very first processor, called the 4004. The chip was aptly named because it had exactly 4004 transistors on it. According to Jonathan Fields, a writer for BBC News, the company released its newest addition to the line, codenamed the Tukwila, crammed with over 2.05 billion transistors. Here's a progression of Intel's creation of its processors all the way from 1971 with the 4004 to the Tukwila in 2008. Intel has been able to fabricate transistor processors with more and more transistors simply by shrinking the sizes of each of the individual little transistors on there. However, we're approaching a fundamental physical limit for the minimum size of a transistor, thus foreshadowing a plateau in future processor speeds. As an electrical engineering student, this is very pertinent to me. However, since all of us desire cutting-edge technology with electronics, it's going to be relevant to all of us very soon. So, in this discussion, we'll dissect the transistor, look at some of its major components. Then we'll move on and try to establish a relationship between transistors and processor speeds, which is what's really important to us. And finally, we'll try to discern the chief reason for why transistors cannot continue to shrink forever. So first, let's take a look at the transistor. Well, a transistor is a circuit element that regulates current flow. According to ScienceDaily.com, a website that specializes in science and technology, the average transistor ranges between 25 and 45 nanometers. To put this into perspective, that's about 1/1000th the size of a human hair. Characteristically, transistors have three terminals. The source, over there on the far left, where the electrons can flow in to the circuit device. The drain, where they exit out. And the gate, which is what regulates the current flow, depending on the voltage applied across. Now, in technical terms, transistors are referred to as MOSFETs, which is a metal oxide semiconductor field effect transistor. However, I like to think of them as little mini drawbridges that we put in circuits to either let current pass through, if we want, or not at all. So, now that we know a little bit about a transistor and its functionality, let's see how it's linked to a computer processor's speed. Well, the speed of a processor is directly related to the number of transistors it has on it. This relationship has been governed by Moore's law since it was conceived in 1965 by Gordon E. Moore. At the time, Moore was the president of Intel, and he noticed that there existed a relationship between the number of transistors on a processor and its corresponding speed. However, it was another scholar named Jan Bordowski who noted that Moore's law sort of implies that a processor speed will double every 12 to 18 months if the number of transistors on it continues to increase exponentially. So here we have a graph showing the number of transistors on processors increasing as they come out with new ones. Alright, so now we know a little bit about Moore's law, but what we can infer from this is that processor speed should continue to double approximately every 12 to 18 months from now until eternity. But we know this can't be true. We know there must be some cutting point, some limitation. And what is this? Why can't transistors continue to shrink forever? Well, according to quantum physics, there's a fundamental size limit that transistors must always remain above. This is a picture of a transistor that's approaching this fundamental limit. It's taken with an electron microscope, and so it's on the order of electrons and protons. But we can sort of visualize this more with the drawbridge example. If the dimensions of the drawbridge were to shrink and shrink and shrink, the cars wouldn't be able to travel across it rather. And much is the same with the transistor and the electrons trying to flow through. So if it were to approach the size of the electron, it wouldn't work out. It was actually Gordon E. Moore who noted at a recent Intel news conference that in a decade or a decade and a half, we'll reach this fundamental turning point. Although it's pretty difficult to determine when exactly we'll reach this make-or-break year, researchers such as J.R. Powell have computed that it could occur approximately around the year 2036. So in conclusion, I'd like to reiterate that this roadblock in future processor speeds will cause a limitation in future electronics technology. And what that means for us is that we won't be able to get our new iPods or cell phones on a recent basis like we're used to, having them on an annual basis being upgraded. That won't happen anymore. So in this presentation, we've taken a look at what a transistor is. We've tried to establish a link between transistors and processor speeds. And we've underscored the chief reason for why transistors cannot continue to shrink forever. It should be becoming clear now that transistors are approaching a fundamental physical limit, and that this will cause a leveling off of processor speeds in the very near future. This is a graph showing Moore's Law pre-2003, and this is a graph of the predicted Moore's Law. It's going to start to level off with processor speeds starting to reach a plateau in the future after 2015. Unfortunately, this isn't a hypothetical situation that the computer industry may have to deal with. This is a reality that they inevitably will. Thank you.